In this short video, we're going to talk about electrical current. So, current happens whenever there is electricity flowing. And here again, I have the ampere, and it's circled in yellow because that's one that you needed to be able to find. It's a unit of electrical current that tells you how much electricity is passing a point per second. And so here I have this water container, and if you looked, say, right here, how much uh, water is going through would be the analogy. But here, usually we're talking about some wire, and if you looked right here, how much electricity or negatively charged particles is passing this point per second. And so that's the ampere. And we abbreviate ampere with just a capital A. So we would say 0.5 capital A. And it's abbreviated in speech as amps. So I would say this is 0.5 amps, or this is 2 amps, or 1 milliamp for a little m. Or this washing machine needs 5 amps to run correctly. Okay? Current is measured at a point with a digital multimeter. Okay? And so here I have a circuit, and it consists of a resistor. This little squiggly line here is a symbol for, this up and down line is a symbol for a resistor. And then I have this symbol here, that's for an LED. An LED is a light emitting diode. And then I have a battery. This is the symbol for like a 9-volt battery. And if you look at the circuit here, normally this would be connected. So the lines represent just wires. And so I have a battery, a resistor, an LED, a light emitting diode. And then what I'm showing here is my multimeter, and it's measuring current. And so I would hook it up at this point. Normally this would be just a continuous line, but I'm putting it in at that point. I'm breaking the line and sticking it in there. So the current flows through the meter. And then if I read this thing, it would say the current going through the circuit is 73 milliamps. The little m is for milli. That's SI units. And here again is another term that you need to be able to define circuit. So a circuit is the path that electric current travels from the source, and the source would be the battery or the electricity coming from the utility company to your house. So a circuit is the path that the electric current travels from the source to the load and back to the source. So the electricity always wants to go back. So if I draw a little red line here, the electricity always wants to go back to the source. And so the load is anything that consumes power. So if you put electricity through a resistor, it'll get hot and consume power. If you put electricity through a light emitting diode, it will warm up, so that's some loss of power, but it's also emitting light, and that's another loss of power. So here again, we can look at our definition. A circuit is the path the electricity travels from the source, that's the battery, to the load, those are the things that consume power, back to the source again. And here I've said there must be a potential difference, there must be a difference in voltage for the current to flow. And so if I have a 9-volt battery, this point here, because the battery is 9 volts from here to here, is 9 volts. And then we have a voltage drop because we lose some power over the resistor to 1.7 volts. And then we lose some power over the LED. And now we're at 0 volts. So the battery's here at relative, and that 0 volt is over the battery to if we just say the negative terminal we're calling 0, and then the positive terminal is 9 volts. So if I take out the battery, then every point is 0 volts, okay? And the resistor doesn't heat up, and the LED doesn't produce any light because everything's at the same voltage. There's nothing providing any power or voltage to get the current flowing.